All right, 8th grade, lesson 5.4, solving special systems of linear equations. You're doing your warm-ups. Okay, so we're going to solve this system using any method we prefer. I'm going to see what they chose, but what would you guys choose?
Wait, what?
What method would you choose? Would you want to graph this?
No.
No. Would you want to use substitution or elimination?
Elimination.
Elimination would be, do you have to do anything for elimination? Yes, we'd have to multiply one of those times -1. Is there another way we could do it?
Yeah.
Substitution.
If we did substitution and set this one equal to this one, we could just solve for x. Which one did they... Oh, they chose graphing.
Ew. 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 So dynamo.
So, harsh, man. Jeez. All right, so we're going to do it...
That's me. Okay.
And we're going to do it by substitution. So we have y equals 3x, write this down in your journals, plus 1. Y equals 3x minus 3. So substitution, if I have anything solved for a variable, then I can set it in the other variable. So since these are both solved for y, I can just set 3x plus 1 to equal 3x minus 3. And solve. All right. So, I have... Oh, okay. So I'm going to subtract 3x from that side, subtract 3x from this side. Interesting. If I do that, what do you get?
X or 0?
41.
Okay, can 1 equal 3?
No. But 3 can...
So then do these lines ever cross?
No. So there
It's a no.
or no solution.
So you're already done. No solution.
Take
I remember that.
How do you get...
Wait, just how much spit it in.
No idea what you just
I
said.
don't know what I was...
He's saying
That's when she had that.
I just brought down the 1 and the -3.
Come on, guys.
Because what I did is I just subtracted the 3x, which canceled the 3x, so I'm left with 1 equals -3. Which you can't do. You're done. I could solve it and I'd get 4 equals 0. But that still is not a solution. 4 cannot equal 0. Okay? So, some of these special equations mean you're going to have no solution. Remember, we're looking for where the two lines cross. We're looking for one point, an x comma y. That's a solution. So if the lines never cross, see how they're parallel lines?
Yeah.
They never cross. There's going to be no solution. Now, let me show you a little cheating shortcut. See how these are in slope-intercept form?
Yes.
Look at the slopes. Are they exactly the same? So we have the exact same slope with different y-intercepts. That should tell you these are two lines that are parallel. They will never cross.
Okay.
So you could have actually solved this without doing any math.
So something with the same slope is always going to be parallel?
Yes, but you have to have different y-intercepts. Point to that. If you have the same y-intercept, if this is y equals 3x plus 1, and the second one is y equals 3x plus 1, how would you graph that?
Oh, it would just be the same thing.
It'd be the exact same line. It'd be a line on top of a line, right? The answer to that is not no solution, because remember, it's where the two lines cross. It's infinitely many solutions, because every single point on those two lines that are identical would be a solution.
Okay.
All right. Go do try it's 1 through 3. So with this lesson, it looks like you're telling me one solution, no solution, or many solutions. Although this first one is probably either
Oh my.
it's either one solution or no solution.
Well, I'm gonna write that down.
Wow, that was easy. I'll explain the choice of method.
I recognized This is your explain your choice of method. I recognized they are parallel lines and would never cross. This is the method you chose.
I can't spell.
Parrellel. Might be one R.
How do you spell recognize?
REC NI. Wow, I have to write it. All right, for example 2, we can choose any method looking at these two equations. Is there a method that jumps out at you that you want to do? Elimination. Okay. Substitution or elimination works on these guys, or graphing, if you like graphing. Okay. If I were to do substitution, all I do is move this 2y over here, and then I have solved for x. Okay. But let's do elimination, because we haven't done an example in elimination lately. So we have x, write this down, plus 2y equals 6. And then we have 3x plus 6y equals 18. All right, in order to use elimination, we need to get opposite coefficients. So, do we want to get the y's to cancel or the x's to cancel? The y's. The y's. Okay, so this is a 6y. What would I multiply times 2 to make that a negative 6? So we're going to multiply this whole thing times negative 3. Okay, so negative 3 times x would be negative 3x. And then we multiply this negative 3 times negative 2, and we get negative 6y. Negative 3 times 6 would give me what?
Negative 18.
So what do we notice?
It's infinite.
Everything is exactly the same. We're going to end up with 0 equals 0, right?
Infinite.
Is 0 equal 0? Yes. So this is infinite. Infinite. Is that how you spell infinite?
I don't know.
Many solutions. That basically means we have a line on top of a line if I were to graph it. If we had solved these for slope-intercept form, they would have been in the exact same line. Okay? So recognize this. When you come out with 0 equals 0, this is infinitely many solutions. Okay? If you rearrange your equation and you notice that the slopes and the y-intercepts are the same, you don't have to continue. You can just automatically jump down and say infinite many solutions. What questions do you have?
So you know how in the other example you could see if it was no solution?
Yes.
Is it possible for this one?
So, yeah, if you can do a little bit of math in your head. So I look at this and go, okay, if I want to cancel out this 6, I go times negative 3. All of a sudden I'm looking at it and I go, well, that's a negative 3. That'd be a negative 6. That'd be a negative 18. You would automatically see it without doing it. Or if you can, in your head, put these in slope-intercept form. It's not as readily noticeable. Okay? Any other questions? Just for fun, I want to see what they did. Oh, they graphed it. So they drew the first one, and then they drew the second one, and you'll notice it's right on top of the first one. And then they did do elimination and got 0 equals 0. All right, go do your try-its 4 through 6, self-assess through number 15. So you're going to work for a few minutes, and then we're going to do our last example.
Okay.
All right, 8th grade, last example, example 3. You and your friend plant an urban garden. Do you guys know what an urban garden is?
Community garden. It's like the Marvin Gardens.
It's a garden in the city. That's all it means, instead of in the country. Urban. Mm-hmm. Usually you'll see these on top of skyscrapers, sometimes in front yards of apartment complexes, stuff like that. You pay $15 for 6 tomato plants and 6 pepper plants, and your friend pays $22.50 for 9 tomato and 9 pepper. How much does each plant cost? So first we need to make our 2 equations. How would we write these 2 equations?
6x plus 6y equals 15.
6x plus 6y equals 15 would be the first one. And the next one would be 9x plus 9y equals 22.50. And you could put that in decimal form. Very good. So now that I have my 2 equations, did you guys get them all written down? Let me wait. Pause. Uno momento. Shh. We're going to solve for how many plants each of us bought. Shh. So, what method do we want to use here? Substitution, elimination, or graphing? Elimination. All right, so how would we use elimination? What do we need to do? Yeah.
Yeah, 1.5.
There we go. Yeah. So if you multiply times 1.5, then a negative 1.5, then everything on top would become the same. So we get 9x plus 9y equals, well, and we did negative. I don't know why they don't do negatives. But negatives, and then you add them and you get 0 equals 0. What does 0 equals 0 show you? That the system has infinitely. So you would tell that there is not enough information to find the cost of each plant. Since this is a word problem. I would let you put not enough info. Not enough info. All right, any questions? Okay, I'll leave this up for a few minutes for you to finish. Stop talking. Make sure you finish all the way through number 17 before tomorrow.